Okay, let us discuss this problem. So this says two identical buggies move one after the other due to inertia without friction with same velocity v0. So let us say we have a rail, and over this rail there is no friction. So this rail is something like this, and there is another rail. This goes with velocity v0, and this also goes with velocity v0. And the question says there is no friction between rail and the buggy's tire. Basically it is not good to say tire, these are wheels. So this is mu is equals to 0. That is, friction is absent in this situation, motion is without friction. Now the next part says a man of mass m rides the rear buggy, and certain moment the man jumps into the front buggy with speed u related to his buggy. Let us say there is a man inside this buggy also. Basically question say rides in the buggy. Basically, so this rides from this side so that the momentum in this direction does not change. So man rides this buggy from the perpendicular to this train or perpendicular to the rail so that it does not change the momentum in the horizontal direction. Or you can consider this something like this. The man is still inside this buggy. So let us assume there is a man that is also inside this buggy of mass m, and this whole system is moving with velocity v0. Are you getting? So let us say you have to assume that initially there is a system with mass of minus m, and the mass of this is capital M, that is the buggy mass is capital M, and this system is moving with velocity v0. This has mass m and moving with velocity v0. Now this man after some time jumps to this with a speed u relative to this buggy. So after some time what is happening? This man try to jump in this one. So what will happen? This man will, when this man jumps to this buggy, this will push his buggy to in the back side. So this will gain a new velocity. So let us say new velocity of this buggy is, I think you are able to understand, and this is important. This becomes v1. Are you getting? Now man is in the air, and its a speed relative to this is u. So what is this speed relative to ground? So let us say velocity of man with respect to ground is equals to velocity of man with respect to buggy plus velocity of buggy with respect to ground. Velocity of man with respect to ground is, so man is, you have to find this, velocity of man with respect to buggy is, so let us say this direction is a positive direction. So velocity of man with respect to buggy, that is u, that is given in the problem. So this goes in this direction with speed u. Are you getting or not? And velocity of buggy with respect to ground is also v1 in the same direction. So velocity of man with respect to ground is u plus v1. Are you getting? So this man is basically moving in the air, u plus v1 velocity. Are you getting? So now man is here, and this is moving with a speed v1. So let us try to understand what is happening. So I have a system, this system, buggy plus man system. Both system is moving with velocity v0. Man jumps to this buggy, leaves his buggy with a speed u relative to his buggy. Now what will happen? If you want to jump from this buggy, you can jump only if you just start running on his buggy. You start running on his buggy, and if you run, basically what you are doing, you are pushing your buggy in the back side. So the velocity will not remain v0, it will decrease, because you are running, you are pushing by leg, you are pushing this buggy by your leg in the backward direction. If you want to just jump, you cannot jump without running. You cannot jump just standing, and you cannot jump in the forward direction. You can vertically jump just by standing, but you cannot jump in the forward direction without pressing this buggy into the back direction. So once you start pressing the buggy in the back direction, the velocity v0 will change. Let us say final velocity is v1, and your velocity, that is the velocity of man with respect to his buggy, is u. So velocity of man with respect to ground is u plus v1, because this has a velocity v1 and this is also a velocity of u. So total velocity is u plus v1. Now I can apply momentum conservation for this system. So this is my system. So man plus mass system. So this is my system. So I can apply momentum conservation for this system. Are you getting? So we can apply momentum conservation for this system. This is initial system. This initial momentum will be, so both are moving with velocity v0, so m plus m into v0. Final momentum will be, so this is moving with velocity v1, so m into v1, plus this is moving with v plus u1, u plus v1, so m into u plus v1. So we will have m plus m v0 is equals to m v1 plus m into u plus v1. Now you will have m plus m v0 is equals to, let us take v1 common, so we will have m plus m and plus mu. So if you solve for v1, you will have v0 minus m by m plus m. Are you getting? M by m plus m and into this is minus m by m plus m into u. Are you getting? This is the final velocity of buggy 1. Now similarly we can solve for buggy 2. Now I will give you a hint and I will wait for some time to check your answer. So what you have to do is, now this man that is coming with a speed u plus u1, so what is happening? Now this man is in the air with a speed u plus v1. This man is in the air with a speed u plus v1. And this buggy, that is the front buggy, at this point of time is still moving with velocity v0 because its velocity has not changed. And after some time we will find this man lands on this buggy. So this man is landing on his buggy, this buggy. So man is now here. Are you getting? Now this system will have different velocity because momentum conservation, this will press this buggy. Basically when this comes here, it will press this buggy to in the forward direction. So let us say the final velocity of this buggy is v2. So you have to apply momentum conservation in this case and give me the answer for v2. I will wait for 1 minute. So let us find velocity v2. So now this time this is my system. I am still waiting. So this is my initial system. And this is my final system. So this is my, so apply momentum conservation on these two systems. So this is my system. Are you getting? So this is my system. Apply momentum conservation on this system, you will get v2. Easy one. Everybody can do this one. So this velocity is v0. Initially you have v0 velocity. Okay, let us again apply the momentum conservation in this case. So this is my initial system. In this case I have to find P initial. In this case I have to find P final. So if I find P initial, the momentum of man is m into u plus v1. And the momentum of this is m into v naught. So plus m into v naught. And the final momentum we will have, both are going with velocity v2. So m plus m into v2. Now if you create these two, so you will have m into u plus v1 plus m v naught. This is equals to m plus m into v2. Are you getting? Now if you solve for v2, you will have, let us plug the value of v1 first and then we will discuss. So m into u plus, what is the value of v1 that we have found in the first part of the question? You can see your copy. So this value here we have v naught minus mu divided by m plus m. So this plus v1 is minus mu divided by m plus m. So this is the value of v1 plus m v naught. This is equals to m plus m into v2. Are you getting? Now if we try to solve this equation, so m, this is m plus m into u plus m into v naught. So we will have, that is a small m goes, so we will have mu plus m into v naught divided by m plus m plus m v naught. Are you getting? This is equals to m plus m into v2. So let us try to solve this one. So what we have, if I take m plus m as LCM, so what we will have, or let us cancel this m plus m. So we will have m into u divided by m plus m plus a small m v naught plus m v naught m plus m v2. Are you getting? Now if I take m plus m here, so v not common, so I will have mu by m plus m plus, if I take v not common, I will have m plus m, and this is m plus m v2. Are you getting? So if I solve for v2, what we will have v2 is equals to, so this v naught plus m into m divided by m plus m whole square into u. Are you getting? Now let us check this one. So this is the final velocity of buggy number 2. So you see in this question, what is the important point we have? The important point we have is, you have to consider the system. How to choose the system? Initially it is given the system is moving with velocity v naught and the man lives with respect to his buggy with a speed u. So you can take the system as buggy plus man as one system. So buggy number, the back buggy plus man as one system. Next time man plus the front buggy you can take as a next other system. So choosing the system is important in this case. What system you are choosing, that is important. And the concept of relative motion is also important in this case. It is given when the man jumps, his speed is u with respect to his buggy. But now the speed of his buggy will not remain same as initial velocity v naught. Basically it has changed. Now its velocity is u. So the velocity will be different. It will be, let us say this velocity is v1. So I have to find what is the velocity with respect to ground. The velocity of buggy itself is v1 and the velocity of man with respect to buggy is u, and both are moving in the same direction. So this means velocity of man with respect to ground is v1 plus u, because both are moving in the same direction. This man is moving with the speed u, and this trolley is also, the buggy is also moving with the speed v1. So the total velocity will be v1 plus u. So simple. Are you getting? If somebody says this is moving with the speed u in this direction and the buggy is moving in this direction with the speed v1, so the total velocity will be u minus v1. Are you getting? We'll discuss the next problem.